I'm going to show you how to do exploratory data analysis in Python. I think a lot of people are daunted by how do I get in and use Python to explore my data. It's definitely one of the earliest things people do with Python. So I'm just going to show you some great functions and great tricks you can use. I think in terms of exploring data, there's a million different ways you can do it in terms of the ordering and what column to explore first and what functions to apply in what order. So I think in this video, pay less attention to the actual order, but more to the operations and functions I'm using. And then you can obviously incorporate those into the analysis you're doing based on what data you have. So today we're looking at Netflix titles, which is a data set I've used before. I think it's a really good data set with familiar data to people. It just basically shows the different titles that are available on Netflix, the different movies and TV shows. The first thing I'm doing is just passing that CSV in as my data frame. And then I'm using df.info. This is going to return some great initial information about the data frame. So the first thing here is we can see how many entries we have, which is going to come back into play later. So we have 7,787. And then also we have for each column what the data type is and how many non-null values are in that column. So we can see that. So we can see some of these columns here definitely do have some null values because there's not the amount of the total entries. And then here we can see most of these columns are objects and one integer column, which is the release year of these titles. Next thing I'm going to do is just check for duplicated values. This is the function I use to do that. We can see there are 0 duplicated values, which is really nice. And the next thing I want to do is for the column of this release year. So this is how we select a specific column. This is the syntax for that. For the column of release year, I want to see what the unique values are. So it prints out this array, which shows me the unique values. And then for those unique values in release year, I want to see what the value counts are. So how many entries do I have for each of those years? Here we see it prints out, we get a rough understanding. There's 73 unique values here, and we get a rough understanding. So, okay, we can see the values, more close to present day. We have a lot more values, a lot more entries there than it seems like the values back in the 50s and 60s and 40s and 20s even. And now as I go down here, this is what I'm doing is I'm checking for null values in the different columns. So is null, is that null function, and then I'm summing for each column how many null values there are. So we can see only 5 of the columns have null values. It's director, cast, country, release year, and sorry, not release year, but rating, and date added is another one. And now what I want to do is I want to replace these null values with zeros. So a lot of people want to get rid of null values in the data. So I'm using this function here, the df.replace. This is the numpy nan structure, and I'm replacing any nan with 0. And so then when I do the is null function again to count the null values, we can see it's all 0. So we've replaced all these null values. Down here, I'm applying a filter. Definitely a really important thing to do when you want to explore your data and even getting into like slicing and dicing data as well, though that's sort of the step after data exploration, which I have other videos on. Here, what I'm doing is just applying really some filter. Here's the syntax of that. We're basically putting the parameter in here. I want this column to be greater than 2018. So I only want to see the rows where this column or release year has values greater than 2018. And when we do that and print out this new data frame df2, which is the filter data set, we can see in release year, we're getting all those columns. Now, as I scroll down here, I'm applying another filter. I'm creating a new data frame. So I'm applying a second filter on that second data frame. So this is our third data frame, which will essentially have 2 filters applied to it compared to the first data frame. And what I'm doing is I'm looking at the country values, and I only want to look at the values where it's Brazil. So I only want to look at the movies and TV shows that are from Brazil, essentially. And then when I print that out, we get Brazil here. We see this prints a pretty long data frame, which is because it's small enough that it's actually going to print the whole thing. And if I want to know how many values I have in that, how many entries I have, I'm just going to do df3.info, again, which is the function I used above, and we'll see there are 37 entries, which is really useful to have. Now I'm going to apply a box plot. So normally this will return box plots for all the numerical variables. We only have one here. So it's returning a box plot for release year. We can see that this box plot, which is again for the original data set, not this df3, is showing that most of the data is up here towards current, which is something you already knew, but definitely visualizing those insights is useful as you go through, and might be more useful for the data sets we encounter. For the df type, which is again one of our columns here, it's type. I'm applying this function here to look at the unique values, which is a really important thing you might want to do. So I'm seeing that for type, we have TV shows and movies. And if I want to see just a histogram showing the distribution there, I can see that. I can apply this hist function super easily. This is from matplotlib. And we'll see we get movies and TV shows here. So we can see we have, I want to say almost double the amount of movies of TV shows. And then here I'm describing the country column, again, for the original data set. We can see there are 7,280 counts, 80 values here, 681 unique countries present. The top country present is United States, and there's about just over 2,500 entries from there. So this is a lot of good information just in this really simple function, .describe. But this is, again, it's a .describe for a singular column. And then the last thing I'll show you here is just the correlation function. So that's going to give us a correlation matrix for all the numerical values. Again, we only have one integer value in this data frame, which is a release year. So we see we're only getting one example here. But obviously, if this was a data set with much more numerical values and less of these strings, less of these objects, then we would see a much more complex correlation table, correlation matrix. So these are a bunch of functions you can use. I hope these are helpful in terms of your exploratory data analysis. As I said in the beginning, there's a million ways to do it. There's no like key 10 functions or anything. There's lots of things you can do, and also the ordering you can do in a lot of different ways. But I basically wanted to show you here functions I use a lot, how you can use them, and how they're valuable. So I hope this was helpful. Thanks, and hope you check out some more of our videos.